So welcome to tonight's lecture, and I'm going to focus on Earth Day and its significance. So we're in Intro Bio, and this part of Intro Bio really focuses on the organisms in the world they live in. What got me into this was my passion for conservation and protecting the planet Earth. I want you to think back. You were probably 7 or 8 years old at the time, to this day, April 20th in 2010. One of the more pivotal moments in environmental history occurred on that day. And as I said, you were 7 or 8 years old, so you probably didn't hear much about it initially, but then you may have heard about it in school, you may have seen things on the news. And what happened on this day in 2010 was the Deepwater Horizon oil spill in the Gulf of Mexico. So one of the largest oil spills in human history led to the death of lots of different organisms that lived in those environments, contaminated the shoreline of Louisiana and all the way to Florida, and had pretty significant impacts on the planet. And that oil spill is just kind of one of the pivotal moments in the environmental movement. So I want to kind of walk back in time to some other things that were pretty pivotal in the environmental movement. So the Cuyahoga River that runs through Cleveland was a river that a lot of industries were along, and they would pollute that river pretty heavily, to the point where multiple times in the 1960s that river caught on fire. I left you the other day with this picture of a scientist at MSU looking at dead robins that they had collected during their morning bird walk. All of these things kind of go together into the birth of the modern environmental movement. And so there was a scientist here at Michigan State University who I was lucky enough to hear speak when I was 12 years old, after he had retired from MSU and was going and talking to different organizations. I went to an Audubon Society meeting. He was our guest speaker. His name was George Wallace, and his discipline was ornithology, so the study of birds. And what he found in his bird classes in the late 1950s and early 1960s were hundreds of dying birds. And he showed photos at this meeting that I was at of piles of birds that they would collect as they would go do their morning bird walks around campus. And there were just hundreds of these dying birds. Well, an author named Rachel Carson found out about the work that he was doing and began to highlight it in a book she wrote called Silent Spring. So probably most of you have heard of Silent Spring. I know somebody talked to me the other day and said that they actually read it in their AP Environmental History or Environmental Science class. And it's got some great parts to it, and it's also a little bit hard to read too, because the main section, a lot of the sections are very technically laden about the impacts of chemicals in our environments. But she communicated with George Wallace about what was going on with birds, and she wrote that book, Silent Spring, in 1962, so 60 years ago now, and that book really launched the modern environmental movement. So I'm going to go through a little bit of a timeline here about the environmental movement, and we'll start in 62 with the publication of Silent Spring. Later in that decade, we had things like the Cuyahoga River catching fire, the first Earth Day in 1970, and then as we move forward, we see the creation of the Environmental Protection Agency in 1970. These are some pretty major events, right? The Environmental Protection Agency, to think that we lived in a country that didn't think about the environment and didn't have any agency that would protect it, is pretty, kind of surprising. And then in 1973, the Endangered Species Act was passed, the Clean Water Act, and the ban of the substance that was featured in Silent Spring, a pesticide called DDT. Now, we live in kind of a strange world now where environmental issues have become heavily politicized, and one political party tends to be critical of environmental protection and one very supportive of trying to do measures with environmental protection. Now, in 1970 to 1973, those major things happened. The creation of the EPA, the banning of DDT, the creation of the Endangered Species Act, the Clean Water Act, the Clean Air Act. All of those things happened. And they happened under Richard Nixon, a president who was a Republican, and he was responding to an upswell of interest in the environment, largely catalyzed by Earth Day 1970. So Earth Day kind of plays a pivotal moment in our history, and that's why we celebrate it today. It is April 22nd of each year, so 2 days from now, but I didn't think you wanted to come to a talk on Friday night, so we're going to do this today. And so all of those things became kind of the groundwork there. And then as we go forward, we still see that it's not all getting better. So as we go into the 1980s, in 1984, Union Carbide had a massive chemical spill and gas leak in Bhopal, India, and this was one of the worst environmental and human health disasters that have ever occurred. And it's one that's actually kind of forgotten. Has anybody ever heard of the Bhopal incident? So a few people in the audience. So, but it really had a massive toll in terms of human life, in terms of environmental damage. In 1986, we had the nuclear meltdown in what was then the Soviet Union, but is modern-day Ukraine, at Chernobyl. And this was a true meltdown. Nuclear core basically burned its way down into the earth when it overheated, and that area is still contaminated with radiation. And then in 1989, in 1986 to 1989 was when I was actually a college student here in Lyman Briggs. And in 1989, the Exxon Valdez oil spill in Prince William Sound in Alaska occurred. And again, a very important thing that really raised the consciousness that it's not just getting better. Some things were improving, but there were other things that were still huge environmental problems. As we went into the 90s, Earth Day 1990 was a pretty big event, and I was actually the MSU president for the Earth Day Club here at MSU and organized the Earth Day 1990 activities, so the 20th anniversary of Earth Day. And things were looking very positive as far as a global, national and global movement toward environmentalism. So in 1992, we see the Earth Summit, which was put on by the United Nations and held in Rio, and members of every nation of the world went there to look at ways to better protect the environment. 1997, the Kyoto Protocol was signed to help limit the use or the emissions of carbon dioxide, which then had become clear was tied to climate change. And so it looked like things were heading in a direction where this was going to be taken pretty seriously. Unfortunately, politics in the United States got in the way and really derailed the Kyoto Protocol and kept that from ever being very effective in curtailing climate change. We move forward into the 2000s, and we have some dark events in the 2000s with Hurricane Katrina, a storm that was likely made much worse due to climate change and a warmer ocean that it developed over, becoming a more powerful storm. And in 2010, what I talked about earlier, On this day, 12 years ago, the Deepwater Horizon oil rig exploded, and the oil well that was a mile under the sea began to spew oil into the Gulf of Mexico at an uncontrolled rate. Into the next decade, we see the Fukushima disaster in 2011, a nuclear disaster there in Japan. In 2018, we reached the dubious level of 405 parts per million of atmospheric carbon dioxide. So why is this number significant? We were at 270 parts per million of carbon dioxide in the atmosphere before industrialization happened starting around 1850. So prior to 1850, for much of kind of the human era, atmospheric carbon dioxide was around 270 parts per million. Well, you multiply 270 times 1.5, and you get 405. So we reached 405 parts per million in 2018, and a lot of people are concerned that that is a point of no return for climate change. And then in 2019, we get to the point where climate change has really started to impact pretty much every part of the world. We know the Arctic had issues with reduced sea ice and melting. And then the Amazon had very widespread forest fires in 2019. So as we think about this, we can kind of think about, where do we want to be? Do we want to be in an era where we're thinking about environmental successes or environmental disasters? And that's kind of what spawned Earth Day initially. So Earth Day is held on April 22nd. And the first Earth Day was in 1970. And this is a picture of people marching on Earth Day trying to raise awareness about environmental issues in 1970. In 1990, the event that I was heavily involved in, we had 2 different concerts here at MSU. We had a whole week-long series of speakers. And worldwide, over 200 million people participated in Earth Day activities that year. Earth Day 50 would have been in April of 2020, and you all know that you were basically locked in your house in April of 2020. I felt really bad leading up to that time that I didn't really do stuff here on campus to try to get students involved and try to get a big Earth Day celebration. In the end, it would have all been for naught, but I would like to see in the future, students do get engaged in environmental issues and trying to do things to raise awareness around campus. I was at a workshop today on climate change with all kinds of leaders of the university, different deans, the provost and president of the university were there, and talking about students and how real some of these issues are to students and how important they are, and that your generation, more than my generation, does recognize the existential threat of these. All right? So Earth Day the initial Earth Day really set in motion things that really did help us start to address some major environmental issues in our country. All right? So some of the environmental initiatives, the creation of the Environmental Protection Agency, the Clean Air Act, the Clean Water Act, the ban of DDT, the Endangered Species Act, all of those culminated right around the time of the initial Earth Day and were great movements, great progress, and allowed for starting to try to address some environmental problems. So here I have a little video, and I'm going to talk about, let me see if I can make this video work. So this gets back to where we started, where we left off the last class and where we started tonight. And this is the research that was done here at MSU looking at the impact of DDT on birds. And Dr. Wallace and his graduate students identified that DDT was the thing that was killing robins around campus. And other scientists then realized that it was causing not just death, but it was also causing sterility in birds. So the females would have very thin eggshells, the males would often be sterile, and there was complete failure of nesting in birds, especially birds of prey, because remember when we talked about trophic levels, they were at the top of the food chain, and they had massive accumulations of DDT in their system. So one key bird was the bald eagle. The bald eagle, which is our national bird, at the time when I was a child, was an incredibly rare bird in the United States. It had been abundant in colonial times, but by the 1960s and 1970s was incredibly rare. So in 1963, there were 417 nesting pairs of bald eagles in the lower 48 states. Most of those were in Washington or Minnesota. 1974, shortly after DDT was banned, and there had been kind of a reduction in DDT usage leading up to that, the population was starting to improve a little bit. Still, only 791 pairs of bald eagles. And as we move forward, we see that number increase and increase. So when I started bird watching in 1982, there were about 1,400 pairs of bald eagles. It took me a year and a half of serious bird watching to see my first bald eagle. Right? Now, pretty much every day that I go out and look for wildlife, I will see bald eagles. So you can see here by 1999, by the beginning of the new millennium, there were about 6,000 pairs of bald eagles in the lower 48. All right? And you can see probably from the scale of this graph that did go up. And what we see now is that there are roughly 70,000 pairs of bald eagles in the lower 48 states. That's up from 417 in 1963, and a massive increase and a massive recovery, an amazing story that now you will see bald eagles. If you drive from here to Grand Rapids, if you look as you cross any of the rivers, often you'll see bald eagles. If you drive from here northward, you'll often see bald eagles. And this was a species that was headed for extinction before the ban on DDT. So, sorry about the phone. So things can get better. But right now, we're facing another crisis. And as we think about the Earth today and tomorrow, the thing that we really think about is the impact of climate change as we go forward. So climate change is driven by carbon dioxide in the atmosphere. And you can see that historically, before the industrial era began, we started burning coal or having gasoline-powered cars. There was very little carbon dioxide emissions by humans. And now you can see that that's in the range of 35 billion tons of carbon dioxide each year. That has led to a massive amount of carbon dioxide accumulating in the atmosphere and resulting impacts from climate change. Now, one of the things to keep in mind, so it's been cold this spring, right? And you're thinking climate change, we're experiencing, cold weather. There's not really any climate change going on here that you can really think about. Well, what you're experiencing right now is weather. And weather is something that's somewhat unpredictable, somewhat spiky. But when you take patterns over many years, you can create climate. And you can see kind of what the averages are. And what you will see is year-to-year variation or month-to-month variation around those climate averages. And we're not necessarily as concerned about this blue line as we are about this green line. And if this green line is moving, when we say compare the year 1900 to the year 2020, and we see that overall our climate has warmed, that's the climate change that we're concerned about. Now, how do we distinguish these two? I like this quote, climate is what you expect. So we expect here in April that the temperatures will be in the 60s during the day and the 40s at night. Unfortunately, it hasn't met that. Weather is what you get. And there are other things that impact weather, but the main driver of climate in our overall Earth's climate is the greenhouse effect. So the greenhouse effect is that radiation penetrates the Earth's atmosphere, solar radiation. When it hits the ground, it can become infrared heat and be absorbed into Earth's surface. It can be reflected back out into outer space. Or it can be, once it's absorbed, emitted as infrared radiation. And some of that gets reflected back. And that kind of depends, this infrared radiation reflection depends on the layer of greenhouse gases in the atmosphere. And the most common of those greenhouse gases is carbon dioxide. So just to understand how the greenhouse effect really does help, so here we have the Earth, the third closest to the sun, and we have a really nice climate on Earth here. We can tolerate pretty much any place on Earth except maybe Antarctica or the Arctic Circle. Our average daytime temperature is 18 degrees Celsius, so about 60 degrees if you average the entire globe. And our nighttime temperature is about 8 degrees Celsius. Okay, so we see a 10 degrees Celsius or 18 degree Fahrenheit swing between night and day. So nighttime is somewhat tolerable. If we go closer to the sun and look at Mercury, Mercury you expect to be hot, right? Okay, it's close to the sun, 425 degrees Celsius during the day. All right, so if Mercury had the same pattern as the Earth, it would be 415 degrees Celsius at night. It would be very hot still at night. It's actually amazingly cold at night, minus 200 Celsius. Okay, so remember, minus 273 Celsius is 0 Kelvin, the point at which motion stops. Minus 200 Celsius is the point at which pretty much motion has slowed. Almost every gas has condensed into a solid. And so in the daytime, it's at a temperature where everything basically is gaseous. And at nighttime, everything is solid. And it has no atmosphere. It burned off its atmosphere. And so that atmosphere that protects the Earth and keeps the Earth from getting super cold at night or super hot during the day, it's not present on Mercury, and Mercury gets these massive fluctuations in temperature as a result. All right? So again, you think of the atmosphere as a blanket. That layer of greenhouse gases is our blanket. And Mercury, without that blanket, has that 600 degrees Celsius difference between night and day. The Earth has a 10 degrees Celsius difference between night and day. But as we add carbon dioxide to the atmosphere, we are creating a thicker blanket. Right? So what is leading to this addition of carbon dioxide? If we look at the Earth's carbon cycle historically, it basically revolved around plants, and trees would absorb carbon dioxide. Remember, we went over that the other day in class, and adding that carbon dioxide allowed them to sequester carbon, build their tree trunks, And what happened 200 million years ago is lots of those trees died and were buried, and all that carbon dioxide that had been captured in them as carbon was buried underground and stayed there for hundreds of millions of years. So that took a massive amount of carbon dioxide out of the atmosphere and brought us down to that level of around 270 parts per million. All right? So we have photosynthesis, we have respiration, but what happened was there was this massive amount of fossil carbon in the ground that we began to tap as oil reserves and gas reserves and coal, and we burned that and released that into the atmosphere. So it's no longer a balance. It's starting to put more carbon dioxide into the atmosphere every year than photosynthesis can remove. Well, how do we know this? How do we know that this is going on? So in the late 1950s and early 1960s, scientists at a remote location in Hawaii, the Mauna Loa Observatory, decided to measure carbon dioxide in the atmosphere. And so they put out instruments to measure carbon dioxide in the atmosphere. And this is a place that's not near cities, so it's not, cars releasing gas into the atmosphere or anything like that. This is a place that really is isolated. So carbon dioxide in the atmosphere is essentially that it's being observed there is kind of an average of the carbon dioxide over the surface of the planet. And what they found was from the late 1950s onward that carbon dioxide level was increasing. At that point in time, it was around 310 parts per million, up to 390, and now to over 410 parts per million. And that has led to global warming. So global warming is this increased greenhouse effect, the thicker blanket. And people will argue whether this is a natural cycle or something that's caused by humans, but scientists, as they analyze this, find that there's a significant human fingerprint on that relationship between carbon dioxide that we are releasing and global temperature. If we look since the Industrial Revolution began, we can see ups and downs in global temperature. But for the last 100 years, the general pattern has been upward, and upward at a rate that wasn't really observed historically. When we go back and we look at other records of temperature, things like tree rings, ice cores, corals, we can reconstruct global temperature, and we see that it went up and down. So this black line is the average here. Okay? And what we see is that around 1900, it started to go up. We get to the 1960s, and from there on, we have actual thermometer data that we can use, and we see that it is continuing to go up. And this rate of change for this period of time is not something that we have seen in recorded human history. As we look at 2014 and 2015, we see that most of the globe here is some shade of pink or red, meaning it was warmer than historical averages, and much warmer in some areas like in Siberia here or in Alaska. And these are places where there's been very rapid climate change. The one place on Earth that it was substantially colder happens to be the eastern half of North America. And so at that time, even though the planet was incredibly hot, you had politicians saying that climate change was not real because it wasn't hot in Washington, D.C., or hot in the eastern United States. All right. If we look at overall changes in temperature going from 1901 to 2012, every place that there's a plus on this globe is a place where there was a significantly higher temperature in 2012 compared to 1901. Climate change has really impacted things. All right. So, let me go to the next slide. So we look at that, we see that we're in kind of this unprecedented increase in temperature. We have to think about how we respond to that. And one of the things that I do is I study tropical rainforests. And one of the things we can do in response to climate change has to do with tropical rainforests. And one, avoiding future deforestation. But remember that trees have the ability to capture carbon, right? Trees can take that carbon dioxide that we're putting into the atmosphere out of it. So by regrowing trees in areas where tropical rainforests have been lost, we can start to reduce some of that carbon that's in the atmosphere. So I always like to kind of think about things that we've seen in the past as we look toward the future. And this photo is of a pile of logs from northern Michigan at the time that northern Michigan was deforested around 1910. Okay, so Michigan was covered at that time, prior to that time, northern Michigan in white pine forests. And white pine was heavily logged, and basically all of the forest was clear cut. This is a picture I took just a few years ago. This is an area that was logged in 1910 and never grew back. So 100 plus years after it was logged, the forest didn't grow back. And so this is one of the things that I worry about as we think about people cutting down rainforests, that maybe we're going to tip things to the point where they can't grow back. So I study tropical rainforests, and I kind of have this central question because I am very interested in the people element of the rainforest and trying to make sure that people who live in those areas are not forgotten as we try to protect the rainforest, but also help them improve their lives, and trying to avoid loss of all of the rainforest. Now, for example, in the Amazon basin, there are areas that used to be forest that have been pretty heavily deforested. All these pale-colored areas have been forest. And Brazil had very high deforestation until around 2004. They started to get it under control. And then recently, they elected an anti-environmental president who has opened things up, and more deforestation in Brazil has happened. Brazil has the largest rainforest in the world, the Amazon, and so it's a very important place. 4.5 million hectares of rainforest lost in 2019. About 1/5 the size of Michigan, pretty large area. In January of this year, Brazil had its highest month of deforestation ever. And when we think about that deforestation, a single hectare of tropical rainforest, so that's the size of 2 football fields, can hold 360 tons of carbon in the trunks of those trees and in the roots of those trees. 360 tons. So when you look at that area in Brazil, those 15,000 square kilometers that they lost in 2019, that would be 540 megatons of carbon dioxide. Half a gigaton of carbon dioxide released into the atmosphere. So massive amounts of carbon dioxide being released into the atmosphere. We want to be on the other side of that equation. We want to be pulling carbon dioxide out of the atmosphere. All right? So as we think about using tropical rainforests, we should be thinking in the opposite direction. We want to regrow tropical rainforests because they can sequester carbon. This is me with some students that I took to Panama in the early 2000s. We're standing in front of a ceiba tree. And that tree trunk, you can see, there's massive amounts of carbon in that tree pulled out of the atmosphere and stored in that tree trunk. Right? Again, I talked about this the other day in class, but the highest primary productivity, the highest growth rates are in the tropics. So that's where we really should be trying to do this. All right? And we have the ability, if you were to plant 2 football fields or 1 hectare worth of rainforest, you could pull 360 metric tons of carbon dioxide out of the atmosphere over time. So this is one of the things that we could do going toward the future to help reduce the amount of carbon dioxide in the atmosphere. All right. So as we think about it, we have cars that are emitting carbon dioxide, and that can go into forests that can sequester that carbon dioxide. And there are other things, other benefits of this. Poverty alleviation by employing people to grow forests. We can alleviate poverty in some of these areas. Obviously, offset carbon dioxide emissions, slow down tropical deforestation, and slow down global warming. So I was lucky enough to work with a project in the 1990s that was doing this, planting trees to try to create new habitat for wildlife and to try to take carbon dioxide out of the atmosphere. And this is that forest at 15 years old. And here you can see a toucan. That forest was able to support some really amazing wildlife while simultaneously pulling carbon dioxide out of the atmosphere. So at the end, I want to return to this question here about environmental disasters or environmental successes. And I really hope that my generation hasn't fouled things up to the point where people of your generation and people of your children's generations can't correct things and move us more toward these environmental successes. So I do really hope that we, in the future, can get to a better environmental state. And as we think about Earth Day this year, we think about what can we do to achieve future environmental successes. All right, so I've now shown you that I can talk for 45 minutes without stopping.